All right, good evening and welcome to Maths Atoka online class. In today's video, we'll be solving some questions on Math 101. The first one is set, and they said that let U be the, U is the universal set. And they say let U, question number 1, let U be equal to minus 10, comma, minus 9, comma. This dot 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 means it continues like that. So I'm going to have minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is my universal set, and I say that be the set of integers, okay, with each of x, y, z a subset of u. They say it means that x, y, and z are gotten from here, okay. And then look at what they say, that x is a set of small letter x such that minus 4 is less than x, which is less than 4. Now, anytime you have less than, they do not put equal to there. It means it's not going to start from the person here. It's going to start before the person. After minus 4 is minus 3. So it cannot start from minus 4. It will start from minus 3. And because there is no equal to in the other one, it is not going to stop at 4. It's going to stop at 3. Are you getting it now? So for this particular x means minus 3. I'm not starting from minus 4 because there is no equal to there. But this one that has equal to, we start from minus 3. You get that now? And this one will not reach 4 because there is no equal to. It will stop at 3. So I have minus 3, minus 2, minus 1, 0, 1, 2, and 3. Okay? These are for x. Now let's go for y. The element in y said that minus 6 is less than y, which is less than or equal to 6. So it will not start from minus 6, but it will end in 6. So it will start from what? Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6. All right? That is for my y. Then for z, if you look at z now, z said minus 3 is less than or equal to, so it started from minus 3, but it cannot end in 3. It will end in before 3, which is what? 2. So for my z will now be what? Minus 3, minus 2, minus 1, 0, 1, 2, and 3. Am I ending in 3? No, because there is no equal to, so 1 and 2. So it's ending here. All right? And don't forget that they say that all these people are subsets of the universal set. What does it mean? Anybody that you are getting here, here, and here must equally be found inside here. You have to be very, very careful. So if you look at that, they can be found there. So, and the first one said that that we should list the elements of x, y, z. Oh, I did not write that. That's the first question there. List the elements of x, y, z, which I have already listed. Okay, I've already listed them. So the next one they said is what? That we should find x intersection y. Don't forget that intersection means what they have in common. So x intersection y is what they have in common. So if you check x and y, what they have in common, they have minus 3, minus 2, minus 1, 0, 1, 2, and 3. So that's the only thing they have in common. That's intersection for you. So the next thing they say we should find is z prime. Don't forget that anything prime or complement, z complement or z prime, okay? Anything prime means the universal set minus that thing, okay? So kinematics Maths Atoka prime means universal set minus Maths Atoka. And anything minus means whatever element you can find in the left hand side that is not in the left hand and in the right hand side, okay? Like let's take this left hand and right hand for instance, okay? So this thing means minus means whatever that is in the universal set that is not in that z. So that is the meaning of complement. So y complement means whatever that is in the universal set that is not in y. So let us get that now. So I have that minus 3 to this. So what is not here is minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3 is here. So we'll continue from what? 4, 5, 6, 7, 8, 9, and 10. All right? So these are z complement. So the next one, I now said we should find x intersection y union z complement. Now, before you find this, you first of all, you need y union z complement. So permit me to clean here. Where do I clean? Okay, permit me to clean this side. Well, first of all, let me do it. Let me do it here. Y union z complement. Please, union means to unite them, to bring them together, but don't repeat any element. So I'm uniting this one with my y. So if I unite them, I'm going to have this one started from -10. So I'll say -10, -9, -8, -7, -6, -5. So it continues dot 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 till to get to 10. Okay, it will get to 10. So that is that. So the union of this and this is giving us the universal set. It's giving us the universal set. So we now say, what does this and this have in common? That is now this intersection, this one that I've already gotten. Are you getting it? So permit me to clean here. I don't clean there because, okay, but just permit me to clean here. Okay, permit me to clean here. So I now have that what? X intersection y union z prime is now what they have in common. So if you look at that, you see that everybody in X is found inside of this thing. So what they have in common is just that X, or you can be picking it one after the other. -3 is inside there. So -3, -2 is there, -1, 0, 1, 2, and 3. So check it out by yourself. This is exactly what they have in common. And then you are done with that. All right. So that is that. So let's move to the next one. The next question there. So the next question here is a Venn diagram. So let us draw a Venn diagram. Now, you can watch my video on set for you to understand this thing perfectly. There are so many operations of set. We have symmetric, we have complement, we have so many of them. So please watch my video on set for you to understand perfectly. Now let's go to Venn diagram. In Venn diagram, they said in a group of, in fact, in a Venn diagram, where you need to start is from the inside, then you move outside. And then the two things you need to note is that you must start from the inside and move outside. And anytime you did not hear only, please subtract. These are the two key words you need to know in Venn diagram. Then you can draw any Venn diagram. So now if you look at it, they said in a group of 240 students, 140 plays football, 130 plays table tennis, and 106 plays hockey. Now we have three things they are playing, three sports that they are playing. Okay, so I will start from intersection of the three of them. Then I'll now move to intersection of two. Then I'll now move to one person. So if I'm drawing my this thing, let me draw my Venn diagram. I have this now as my Venn diagram. So this is the. So I have my table tennis, I have my football, and I have my hockey. Please, anyhow you want to label it does not matter. Now, if you read out this, read it out. They said in a group of 240 students, 140 plays football, this play this. I'm looking for where they will tell me the number of people that play the three of them. That's what I'm interested in. They say if 70 70 of the students play football and hockey, 2, I'm not interested. 60 plays football and hockey, I'm not interested. 42 plays tennis and hockey, I'm not interested. And each of the students play at least one of the three games. All right. So then I said, how many played all? Oh, they are asking me how many played the three of them. So if they did not give you the number of people that played the three of them, they will be asking you that. So since they are asking me that, I will say let the number of students that play all be X. Okay. Once I've gotten it as X, I'll write it inside here. Okay. Once you write it inside here now we have gotten the number of students that play the three of them. So we now want to get the number of students that play 2, 2, and 2 before we go to 1, 1, 1. You see the way you do it. You must start from the 3, the 2, 2, 2, then you go to 1, 1, 1. That's how to get that. And don't forget that if you did not hear only, you must subtract. But the question is, what do we subtract? So let's go. We have done the 3. Let's go to the people that play 2. They say 70 of the students play football and table tennis. So, but they did not say only. So they want to find only football and table tennis. I'll tell them only football and table tennis will now be that 70, okay, minus x. 70 minus the intersection of the 3. You will now come here and write it that this is 70 minus x. All right. You go to the next person that played 2 again. 60 play football and hockey. They did not say only. Now, another way they can say only is by saying they can say 70 play football and hockey, but football and table tennis, but not hockey. That is another way to tell you only. All right. So if they not mention the word only, they will say but not or but. Are you getting it? If you hear that but, it means they are talking about only that too. So, but since they did not say any of these things, I must subtract. So I will not tell them that only, which one I'm talking about now? Football and hockey. So only football and hockey will now be what? 60 minus x. So you now put it football and hockey 60 minus x. All right. So the next thing you're going to look at is the next one. 42 play both tennis and hockey. They did not say only. So I will tell them only football. Is it football? Sorry. Only tennis and hockey. Only tennis and hockey will now be what? 42 minus the same x. I'll write it. Tennis and hockey is here. 42 minus x. You see that? So the next thing you need to get now, we are done with 2, 2, 2. So let's move to 1, 1, 1. Let's move to 1, 1, 1. So moving to 1, 1, 1, we'll tell them, let's go. They said 140 play football. They did not put only. So how do you do for 1? You will not say 140 minus everything that entered inside of that circle of tennis. That is how to do for 1, 1, 1. Okay? So please don't forget that. So let us get only tennis. Only tennis will now be what? Where is tennis? Okay, 130 play tennis. So only tennis will now be 130 minus the first person that entered inside of tennis. Let me just say, let me pick this one. Arrangement does not matter. So let me say 70 minus x. Please, anyone that is double like this, you must put them in bracket because you are still going to use minus to clear the bracket. If not, you will fail it. Please, always put it in bracket. So the next one is what? Minus. The next person is what? 42 minus x entered inside of this circle, and the last person that entered is what? Minus x entered. So if I clear the bracket, I'm going to have 130 minus 70 minus is plus x. This time this will give you minus 42 plus x minus x. All right, now let's go to the side of x. X minus x is gone, so I'm left with one x here. Now press the other side. I'll have 130 minus 70 minus 42. So I have 130 minus 70 minus 42. So I'm having 18. So this is plus what? 18. I will now tell them that only hockey, which is this place, is what? X plus 18. All right. So let's go to the next one. Only football. Now they said that what? 140 plays football. They did not tell me only. So I must say 140 minus everything that entered inside of football. The first person that entered is what? 70 minus x. It must be in bracket minus. The next person that entered is what? 60 minus x. And then the last person is what? Minus x. So what do I have now? 140 minus 70 plus x minus 60 plus x minus x. So this 2 is gone. I'm left with only this x. All right. So we now say this minus this will give you plus 10. Okay, so only football will now be what? X plus 10. You get that? So the last person now, let's get for only hockey. So only H will now be, let's go again. They gave me that 106 played hockey. They did not put only. So to get that only hockey will now be what? 106 minus everything that entered inside of hockey. Let's say the first person that entered is what? 60 minus x entered. So the next person that entered is what? 42 minus x entered, and the last person is minus x. So what do we have? We now have that 106 minus 60 plus x minus 42 plus x minus x. So what do you have? This and this is gone, so x is left. I'm having 106 minus 60 minus 42. So I'm having 4. So this is x plus 4. All right. So I'm having that here is x plus 4. So the next thing you look out for is for those that did not play any of these three, and they should be written outside the circle. But they did not give us, they said that each of the students played at least one of these. So nobody did not play or any of them. So we don't have anybody outside here. So now, how do you get your x? You get your x by adding everything you are seeing in this box and equate it to the number of students involved. So we have 240 students involved. So I'm going to say, you say everything there, add them. So the first, please, why adding? You have to be very, very careful. You can start from 1, 1, 1, 2, 2, 2, then 3. Or you start from 3, 2, 2, 2, 1, 1, 1, so that you don't make any mistake. So, but I want to start from 1, 1, 1. So I have what? X plus 18 plus x plus 10 plus x plus 4 plus 70 minus x plus 60 minus x plus 42 minus x plus the last person x is equal to what? The total number of students, that is 240. All right. So now what do you do? Please, if you get to this place, you first of all add all the x you are seeing there. Add all the x first. 240. Am I correct? Yeah, 240. So now, see what I'm going to do. Let me concentrate on all the x, and any x I see, I'll call it 1. In my calculator, I'll say 1 plus 1 plus 1 again plus, then now is minus, not plus, minus 1 minus 1 minus 1, then plus 1. So I'm having just plus 1. So plus 1 means nothing like 1x, but just x left. Are you getting me? So now let's move to all the numbers. Let's press it the way I'm seeing it. 18 plus 10 plus 4 plus 70 plus 60 plus 42. So what do I have? 204. So this is plus 204 is equal to 240. So what do you have? X is equal to what? 240 minus 204, which is equal to, so I'm having 36 students. So you will not make a statement that what? 36 students, from what they say, how many played all? You will make a statement that tell them 36 students played all. 36 students played all the 3 games. All right. But don't forget that they say we should draw the Venn diagram. Now, this is the first thing you will do before you draw the next Venn diagram. Now, permit me to clean here. The next Venn diagram you are drawing should be, substituting for x. So you draw the next one to show them you have gotten everything about x. So I have this, and finally this. All right. So I have that this is T, F, and H. Okay. So x is 36. So I have that here is 36. So here is 70 minus 36. So you do that. 70 minus 36. So I have 34. Here is 34. Okay. I have 36 plus 10 is 46. 36 plus this is 40. 36 plus this is 36 plus 18 is 54. Here is 54. Okay, the next one, 60 minus 36. 60 minus 36. I have 24. 24. And then 42 minus 36. 42 minus 36. I have 6. Okay, so that is my Venn diagram. So I've answered the first question. So let's answer the next question. So to answer the next question, they said, they said, how many played exactly 2 of the 3 games? Only 2 of the 3 games. The people that played 2 of the 3 games is what? 34 played two of these. So it is, you will tell them the number of students that played exactly two of the three games will now be equal to the people that played two of these. That is what? 34 plus the people that played two of this one, which is 24, plus the people that played two of this, which is 6. So what do I have now? I'm going to have 34 plus 6 plus 24. So I'm having 64 students. All right. I said exactly one of the three games. So exactly one of the three games, you tell them number of students that played exactly one of the three games will now be equal to the people that played only table tennis, which is 54, plus only football, which is 46, plus only hockey, which is 40. So if you add them, you are going to have 54 plus 46 plus 40. That is 140 students. So 140 students. So Ivy said the number of students that played only football. If you look at that, you see that it is obvious that only football is 46. So you tell them that what? Ivy, that the number of students that played only football is equal to what? 46 students. All right. So that is that for set and Venn diagram. So let's continue to the next question. Permit me to clean. So please, you can watch my video on Venn diagram for more knowledge of set and Venn diagram. So question number 2. So question number 2 said prove by induction that 3 plus 7 plus 11 plus 15 plus plus 4n minus 1 is equal to n into 2n plus 1. All right. Solution. Now we have 5 stages of mathematical induction. Okay, 5 stages of proving something by proving an equation, okay, or a sequence by mathematical induction. So, and the first one is said what? Assume Sn statement is true. Okay, this one is simple. Just say that Sn is equal to, just repeat the question, 3 plus 7 plus 11 plus 15 plus plus 4n minus 1 is equal to n into 2n plus 1. All right, that's the first one. The second one is to prove. You prove that S1 statement is true. To prove that S1 statement is true. What does it mean? S1, anywhere you see n, just put 1. Very simple. Say 3 plus 7 plus 11 plus plus 4 into 1 minus 1 is equal to 1 into 2 into 1 plus 1. So I'm having, please, you keep repeating this side, okay? Keep repeating this side. Then you come here and say 4 times 1, 4. 4 minus 1 is 3 is equal to 2 times 1, 2 plus 1, 3. Then that 3 times 1 is another 3. Once you get that the left-hand side is equal to the right-hand side, if they divide itself, I have 1 is equal to 1. Once you have 1 is equal to 1, you continue. Okay, so but if they are not equal, don't continue. Then it cannot be proved by mathematical induction. But always they will give you the one that you will continue. Okay, so the next one is to assume SK statement is true. To assume SK statement is true, it means SK in the same formula. Anywhere you see any again, put your K. So I have 3 plus 7 plus 11 plus dot 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 plus 4K minus 1 into K in bracket of 2K plus 1. All right, this one is done. Then the next one is to assume that SK plus 1 statement is true. Assume SK plus 1 statement is true. Right? Okay. So what do? SK plus 1. Now, anywhere you see N in this formula again, change it to K plus 1. So I have 3 plus 7 plus 11 plus dot 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 plus, I'm having what? 4 in bracket of K plus 1 before I put my minus 1 is equal to K plus 1 into 2 in bracket of K plus 1, then plus 1. All right. So continue, please repeat this side. Then you come here. 4 times K is 4K. All right. 4 times 1 is 4. 4 minus 1 is 3. So I have plus 3 here is equal to K plus 1 into 2 times this is 2K. 2 times 1 is 2. 2 plus 1 is 3 plus 3. All right. Then the last but not the least, which is the main thing, is for you to prove. This is the main thing. To prove that SK implies SK plus 1. That is the main thing. Don't forget that the first one is what? Assume SN. Prove S1. Assume SK. Assume SK plus 1. And the main one, which is number 5, is to prove that SK implies SK plus 1. Now you have to pay attention here. What do you do here? You just carry the left hand side of SK plus 1. Please write it down. Carry the left hand side of SK plus 1. Add it to the both sides of SK. If you add it to the both sides of SK, then keep solving the right hand side of that SK to get exactly the right hand side of SK plus 1. Let me repeat what I said. Please write it down. Carry the left hand side of SK plus 1. Add it to the both side of SK. Okay? Once you add it, then you now solve the right hand side of that one you have added until you get the right hand side of SK plus 1. Are you getting me? For SK plus 1, you are carrying the left hand side. Then you are solving to get the right hand side. That's all. So let us do that. We are starting from our SK. Our SK is equal to what? 3 plus 7 plus 11 plus dot 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 plus, the first thing there is what? I have 4K minus 1 plus, I am going to add this left hand side. This left hand side is what? 4K plus 3. All right, is equal to, you repeat this side because I'm adding it to this both side. I'm adding, so I will repeat here. K, please permit me to write it here because it's always very long. So let me write it here. I hope you have written this one. So let me write it here. It's always very, very long. So I have prove that SK implies SK plus 1. So from my SK is what? 3 plus 7 plus 11 plus dot 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 plus this, the left hand side, 4K minus 1. All right, let me give space so that you understand what I'm saying. Is equal to K in bracket of what? 2K plus 1. Now, this is my SK, but they say that I am carrying this left hand side to add to the both side. So I'll say I'm adding here plus 4K plus 3. I've added here. So I need to add here again the same 4K plus 3. You see? So once you have added this left hand side to the both side of this SK, just keep solving the right hand side. Okay? Till you get this side. But please be repeating this thing. Be repeating this thing. But I don't have that time. So this time, this will give me First of all, you check if anything is factorizable. Nothing is factorizable. So let me just clear the bracket. This time, this will give you what? 2k squared. This time, this will give you what? Plus k. This plus time, this will give you plus 4k. Plus time, this will give you what? Plus 3. So if you do this, you have 2k squared. This time, this will give you plus 5k plus 3. Now, this is a quadratic equation that you need to factorize. Okay, if you don't know how to factorize, just tell them that that if you factorize this thing, you are getting this. It's obviously that you are getting that k plus 1 and the 2k plus 3. So factorizing this is giving me this. Okay, so I have gotten exactly this. It is proved. But if you want to still factorize it by yourself, you can do that. Okay, or you go and learn factorization from my video on factorization. So I have 2k squared plus 5k plus 3. So in your secondary school, they'll tell you the first and the last, which is 6k squared. Two things that will replace this is 6 and 1. So I have 2k squared plus k plus 6k plus 3. So what is common between here is k into 2k plus 1. What is common here is 3 into 2k plus 1. So what is common between this line and this line is what? Okay. Are you sure there is no mistake somewhere? What is common? Okay. So this is k plus 3 and 2k plus 1. Problem. There is a problem somewhere. Let me check. If you clear this time this is giving me, let's check. This time this is giving me 2k squared. This time this is giving me plus 3k. This time this is plus 2k. Plus is correct. So let me check my own factorization. What is common? Oh, sorry, this is giving me 7. It's not giving me this 5. So I did not get my factorization. So let me redo it again. So this is 2k squared. The two things here can be 2 and 3. Yes, 2 and 3. So 2k plus 3k, correct, plus 3. So this plus this is still giving me 5. So this is the right thing to do. So 2k into k plus 1 into k plus 1. What is common is plus 3. I have k plus 1 and 2k plus 3. You see? So that is that for mathematical induction. So please watch my video on mathematical induction to solve more questions on that for you to be perfect on it. Okay, so don't forget that mathematical induction has 5 stages. The first one is to assume Sn statement. The second one is what? To prove S1 statement. The third one is what? You assume Sk statement, then you prove that Sk, and you assume Sk plus 1, and finally prove that Sk implies Sk plus 1. All right, so that is that. Okay, so let's continue from where we stopped. I'm now looking for the question. All right, so the next one, find the number of ways. The B2B said find the number of ways, find the number of ways in which 13 students can be divided into two groups of 6 and 4 students. 13 students can be divided into okay, so find the number of ways in which 13 students can be divided into I into two groups. Two groups of 6 and 4 students. Now, if you are grouping people, you are not arranging them, you are selecting them. Okay? If you want to group people now, they are 13 and you want to group, which means you are selecting 6 and then selecting 4. Okay? And you want to group them into that. So it is selection. And selection means combination. So what it means that I am grouping 13 combination 6. 6 people out of 13. And the another group I'm having is what? 13 combination 4. 4 people out of this. And means times in mathematics, which is what? 13 combination 6 times 13 combination 4. And what is combination? Don't forget that n combination r means n factorial all over r factorial, then n minus r factorial. So I'm using the same thing here. 13 factorial all over 6 factorial, then 13 minus 6 factorial times the same thing here. 13 factorial all over 4 factorial, then 13 minus 4 factorial. So what is factorial? Don't forget that maybe let me use 5. 5 factorial simply means 5 times 4 times 3 times 2 times 1, like that. So let me have 13 factorial. So I'm having 13 factorial all over. This is 6 factorial and 13 7 factorial. All right, times 13 factorial all over 4 factorial. 13 minus 4 is 9 factorial. So if you do that now, you are going to have so just work it out and get your answer. So this 13 factorial means 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, all over 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. But it is stupid for you to have 7 factorial in the denominator. You still want to repeat from here to here. Do you know that from here to here is the same as 7 factorial? So it's better that if I get to this place, I'll write my 7 factorial times 7 factorial, because I know that another 7 factorial denominator will cancel it. All right? Times, don't forget these people, 13 times 11 times 10 times, instead of writing 9 times this, I'll write as well 9 factorial, because I know that this one is 4 times 3 times 2 times 1 times, because I know that another 9 factorial will cancel it. So 7 factorial take care of 7 factorial, 9 factorial take care of 9 factorial. So I'm having okay, so check out what can cancel. Just multiply everybody in the numerator, multiply everybody in the denominator, and then you divide to get your last answer. All right, but if anything can cancel, you can start canceling. For example, 2 times 5 is 10, it can cancel this 10. Okay, 3 times 4 is 12, it can cancel this 12. So, and then small cancellation. Then I can have that 2 cancel here is 3, 2 cancel here is 4, 3 cancel 1, 3 cancel 3. So for numerator here, I'm left with 13 times 11 times 3 times 4 for this side. So you can do the same thing this side. Okay, you can have that 2 here. 2 here can take care of this to give you 5. So I'm having, just multiply the numerator, then divide it by the denominator and get your last answer. And that is your answer. All right. So use your calculator to get that. And tell me what the answer is at the comment section. Right? Okay. So let's continue. So the next one said, question number 3. Question number 3 said, express 2x plus 3 all over x plus 1 into 2x plus 1 into x minus 3. Right? Then I say in partial fraction. Okay? In partial fraction. Now, resolving something into partial fraction is very, very simple. So what do we need to do? Just small thing we need to do. Solution. You can watch my video on partial fraction, right? This is 2x plus 3 all over x plus 1, 2x plus 1, and x minus 3. All right? So this is equal to a over x plus 1. Because this is a linear, the power here is 1. So I'll have a constant up, plus b over 2x plus 1 plus c over x minus 3. All right? So you can watch my video on partial fraction to understand it better, please. So I have, bring this one down, 2x plus 3 all over x plus 1 into 2x plus 1 into x minus 3, all right, is equal to LCM. Here is the same thing, x plus 1, 2x plus 1, and x minus 3. Now, how do you solve fraction? When the three of them divide this will cancel this. I'm left with these two people. So I'm left with a in bracket of 2x plus 1 and x minus 3. All right? Plus, if the three of them divide this one will cancel this one. I'm left with these two. So I'm left with what? B in bracket of x plus 1 and x minus 3. So finally for C plus, when the three of them divide this one cancel this, remaining these two. So I'm left with C in bracket of x plus 1 and 2x plus 1. All right? So the next thing you do is the denominator cancel denominator. But please don't cancel it in your brain. So just know that this one cancel this one. I'm left with only the numerator. And the numerator is what? 2x plus 3 is equal to a in bracket of, let me multiply. I want to clear this. 2x times this will give you 2x squared. 2x times this will give you minus 6x. 1 times this will give you plus x. 1 times this will give you minus 3. You close. Plus, let's go again. B into, this time this will give you x squared. This time this will give you minus 3x. This time this will give you plus x. This time this will give you minus 3. You close. All right? So the next one, plus c into, this time this will give you 2x squared. This time this will give you plus x. This time this will give you plus 2x, then plus 1. All right? So let me finish up with the people inside because I have two like terms that I can add. So bring this one down. 2x plus 3 is equal to a into 2x squared. These two will give you minus 5x minus 3. All right? Okay? So let's continue. Plus b into x squared. This and this will give you minus 2x minus 3. Then plus c into 2x squared. This and this will give you plus 3x plus 1. Okay? So now let us clear with a now. We are done with everything inside. So I have 2x plus 3 is equal to, this time this will give you 2a x squared. This time this minus 5a x minus 3a. Okay? Then plus bx squared minus 2bx minus 3b. Then finally plus 2cx squared plus 3cx plus c. You get that? Now, once you have cleared everything, now you start comparing. Put your equivalent and start comparing. What do I mean by comparing? Anybody that has s squared in the right hand side must be equal to the person that has s squared here. So let's go. So call everybody you think that has s squared here. 2a has s squared. So I'll bring out my 2a. All right. B has s squared. I bring out my plus b. 2c has s squared. I bring out my plus 2c. It must be equal to the person that has s squared in the left hand side. But nobody has s squared here, so it must be equal to 0 because nobody has s squared in the other side. So you call it your equation 1. I'm done with s squared. Now let me go with x. Minus 5a has x, so I'll bring it out. Minus 5a, who again has x, Minus 2b has x. I'll bring it minus 2b. Who again? Plus 3c has x. I have plus 3c. It must be equal to the person that has x there. Who has x there? Only 2 has x. So it's equal to 2. Equation 2. Now, let's move to those that does not have x at all. So which is what? Minus 3a does not have x. Minus 3b does not have x. Then plus c does not have x. And is equal to what? 3 that does not have x. Call it equation 3. So you will now solve your equation 1, 2, 3 simultaneously. Solve your equation 1, 2, 3 simultaneously. So let us do that. Okay? Permit me to clean here. So how do you solve simultaneous equation of 3 unknowns? Okay? So the first thing you do is you will use equation 1 and 2, eliminate a, still use 1 and 3 and eliminate the same a. So we'll tell them using equation 1 and 2. And equation 1 said 2a plus b plus 2c is equal to 0. And minus 5a minus 2b plus 3c is equal to 2. You are going to multiply these people by minus 5. And then multiply these people by 2 so that they will be equal. They can now eliminate. Don't forget your normal elimination method of simultaneous equation. So minus 5 times this will give you minus 10a, minus 5 times this, minus 5b, minus 5 times this, minus 10c is equal to minus 5 times 0 is 0. 2 times this will give you minus 10a. This time this will give you what? Minus 4b. This time this will give you what? Plus 6c is equal to, this time this will give you what? 4. So now they are equal. I can now subtract. If I subtract, this minus this is gone. Minus minus is plus. So minus 5b plus 4b will give you what? Minus 1b. But there's nothing like 1b, so it will be minus b. All right? So minus minus, minus plus is minus. So minus 10 minus this will give you what? Minus 16c is equal to 0 minus 4 will give you minus 4. So if you multiply everybody by minus, I'll have that b plus 16c is equal to 4. Equation 4. All right? That is if you like. If you don't like, call this one equation 4. You will still get the same answer. So the next thing we are going to do is what? We'll tell them using 1 and 3. Don't forget we have used 1 and 2. So let us now use 1 and 3. Using 1 and 3. So using 1 and 3, I'll have that my 1 is what? 2a plus b plus 2c is equal to 0. And my equation 3 said minus 3a minus 3b plus c is equal to 3. So I'm going to multiply these people by minus 3 and then multiply these people by 2 so that they will be equal. I'm eliminating the same a. So this time this will give you minus 6a. This time this will give you what? Minus 3b. This time this will give you what? Minus 6c is equal to 0. 2 times this is minus 6a. 2 times this is what? Minus 6b. 2 times this is what? Plus 2c is equal to 2 times this is 6. So if I now subtract, they are equal now. Minus minus is plus. Minus 3 plus 6 will give you what? 3b. Minus plus is minus. Minus 6 minus 2 will give you minus 8c is equal to 0 minus this will give you minus 6. So I have my equation 5. So since you have your 4 and 5, you will now tell them using 4 and 5. Using that 4 and 5. So if I'm using 4 and 5, my 4 said that b plus 16c is equal to 4. And then 3b minus 8c is equal to what? Minus 6. Now, I'm eliminating b now. I've already eliminated a. So let me eliminate b. I'll multiply these people by 3, the coefficient here. Multiply, then the coefficient here is 1. Multiply this people by 1 so that they will be equal. 3 times this is what? 3b. 3 times this is what? I think it's 48. 16 times 3 is 48. All right, 48 plus 48c is equal to 3 times this is 12. 1 times anything is the same thing. 3b minus 8c is equal to minus 6. So let us subtract. This minus this is gone. Minus minus is plus. 48 plus this will give you what? 48 plus 8 will give you 56. So I have 56c is equal to this plus this. 12 plus 6 is 18. So I have 18. So therefore my c will now be what? 18 divided by 56. What do you have? 56, 18. Okay, so you can reduce it to the lowest. I think 56 divided, okay, 2 divide here, I have 9. 2 divide 56, I have 28. Okay, so I think 9 over 20, can 3 divide? Okay, so I have that my c is 9 over 28. So what do? You substitute that c in equation either 3 or 4 to get your b. Since I've gotten c now, I will substitute in either equation 3 or equation 4. Sorry, either equation 4 or equation 5 to get my c. Okay, so to get my c now, I will substitute in either equation 3 or 4. Let me use equation 4. All right, if I use equation 4, so using only equation 4, I have that b plus 16c is equal to 4. So therefore b plus 16 in bracket of 9 over 28, right, is equal to 4. So therefore b plus can 28 divide that? Okay, let me just say 9 times 16, 114. So I have 114 over 28 is equal to 4. So my b will now be what? 4 minus 114 over 28. So I have that my b is equal to, LCM is 28. 28 times 4, 112. So 112 minus 114. So my b is equal to minus 2. So minus 2 over 28, which is what? Minus 1 over 14. Minus 1 over 14. So I've gotten my b. So what do now? You will now carry your c and b and substitute in either equation 1, 2, 3 to get your a. So, and that is the last thing. So once you get your a, b, and c, go back to that place you say a, b, and c and substitute it. My board is too small. I cannot continue. So you can watch my video on partial fraction to understand better. All right, this one is too long. This one is too long. I would have solved it last, because sometimes anything that is long like this may discourage students to continue the lesson. So I would have solved it last, but no problem. So the next one, they say 3b. So anytime you see partial fraction, please solve it last, because it will waste your time. And sometimes after wasting your time, you might make a little mistake that might scatter everything you have done. So please solve it last. They said expand x plus 1 over x all raised to power 5, right? And simplify each term. And simplify each term. Okay? Now, if you want to factorize this, if you want to expand this, it's either use binomial expansion theorem or you use Pascal's triangle. But since it is a natural number and it is 5, I can use Pascal's triangle. So I'll do my 1, 1. Please watch my video on Pascal's triangle. 1 plus 1 is 2. If you write in the middle, put 1, 1. This plus this is 3. This plus this is 3. Once you get to the last person, put your 1, 1. They must be on the same line. This plus this is 4 in the middle. This plus this is 6. This plus this is 4 again. 1, 1. Then the last person for 5. This plus this is 5. This plus this is 10. 10 again. 5, 1, 1. Okay, I've gotten to the side of 5. So the coefficient I'm using is what? 1, 5, 10, 10, 5, 1. So see how you do it. So the expansion of this, x plus 1 over x all raised to power 5 is equal to, Call this first person the boy. Call the next person the girl. Okay? And please, nothing can separate them because they are joined together. God joined Adam and Eve. So nothing should separate them. So don't separate them with either minus or plus. They must always be together. What do I mean by that? Let me pick the first one. 1. Adam will start from X. Sorry, we start from this first person, the boy. The boy will start from raised to power 5. While the girl, 1 over X, will start from raised to power 0. The boy starts from 5. The girl will start from 0. Then the boy will be giving the girl 1, 1, 1 till the boy will turn 0. You stop. That's all. Very simple something. Plus, the next person I'm picking is what? 5. The boy will turn to 4 now. And the girl will turn to what? 1. Plus, the next person I'm picking is what? 10. The boy will turn to what? The boy will turn to 3. Okay, let me put them in bracket. All of them in bracket. The boy will turn to 3 and the girl will turn to 2. You keep going. Plus 10 again. The boy will now be 2 and the girl will now be 3. Plus, you continue. 5. The boy will now be 1 and the girl will now be 4. And then finally 1. The boy will now be 0 and then the girl will now be 5. Very simple. You are done. So let us evaluate. They say, because they say we should simplify each term. So if we simplify it now, anything raised to power 0 is 1. 1 times this will give you x raised to power 5 is remaining here. So this is 1 down and 4 up. So 1 dividing the 4 up here, it will remain 3 here. So I have plus 5x raised to power 3. You see that? This is x squared and s cubed. 2 will remove 2 from here is remaining 1. So I'm left with 10x here. Now, this is x raised to power 3. 3 is down and 2 is up. So 2 will remove 2 from down, remaining 1 in the down. So I have plus 10 over x. The x is down. So I have x1 here and then 4 here. Are you getting it now? So remove 1 here, who is remaining? 3. So I'm left with what? 5 over x raised to power 3. Okay? Then anything raised to power 0 is 1. So 1 times this will give you plus what? 1 over x raised to power 5. So that is the answer. Very, very simple. Okay? So if they say raised to power 20, you keep doing this. But they will not give you raised to power 20 anyways. So the next one, 4a, is just 6 questions. I'm in number 4. 4a said divide p of x, which is equal to x raised to power 4 minus 3x raised to power 3 minus 17x squared plus 34x plus 5 by x minus 5. Okay? It's just long division. What do? You draw your line like this and use your DMS. X minus 5 here. So I have x raised to power 4 minus 3x raised to power 3 minus 17x squared plus 34x plus 5. All right? Okay. So now let's go. We are using DMS. So the first one is divide. Divide simply say use the first person to divide the first person. That's all. So this divide by this will give you x raised to power 3. Let me check my time. Okay. So x raised to power 3. Now I'm done with D. We go to M. M said use the answer gotten from D to multiply everybody in the divisor. This is called the divisor, the left hand side. So this time this will give you x raised to power 4 under his neighbor. This time this will give you what? Minus 5x raised to power 3. After that, we go to the next one, subtraction. This minus this is gone. Please, this minus will always affect the people down, please. So minus here is plus. So minus 3 plus this will give you what? Plus 2x raised to power 3. Bring down the rest. Minus 17x squared plus 34x plus 5. All right? Now, the answer gotten after subtraction is called the remainder. This is my remainder. But I am not going to stop until my remainder is less than this man. This is the highest power here is 3. And the highest power here is 1. It's still greater. So I will still continue the DMS again. So I'll go back to D again. Don't forget, D said only the first person is dividing the first person. So this divided by this, you have what? Plus 2x squared. Now you go to m. M said use the answer you got from dividing to multiply everybody here. So 2x squared times this will give you 2x cubed. 2x squared times this will give you minus 10x raised to power 2. Then the next thing is what? You subtract again. So this minus this is gone. Minus minus is plus. So minus 17 plus 10 will give you minus 7x squared. Bring down the rest. Plus what? 34x, then plus 5. So now look at this. The highest power here is 2. And the highest power here is still 1. Is still greater. We continue again. So D again. And this said only the first man is dividing the first man. So this divided by this will give you what? Minus 7x. You go to M. M said use the answer you got from the dividing to multiply everybody here. So minus 7x times this will give you what? Minus 7x squared. Minus 7x times this will give you what? Plus 35x. The next thing you do is what? You subtract. Let's go again. This minus this is gone. Plus minus is minus. 34 minus 35 will give you minus x. Bring down your plus 5. The highest power here is 1. The highest power here is 1. They are equal. We will still repeat the DMS because they say that it must be less than. They didn't say it must be equal. It must be less than. So we go back to D. D said the first person is divided the first person. So I'm having minus 1. Use the answer here to multiply everybody here. Minus 1 times this, minus x. Minus 1 times this will give you plus 5. So if you subtract, you have what? 0. So you now see that what? You must not, it's not a must you get 0. But because we got 0, we will conclude that what? You tell them, this is my remainder. You can tell them, since the remainder, okay, first of all, you can write that the remainder, okay, let me write, see what you write. See what you write. You tell them your quotient. Quotient means your answer. Quotient. Your quotient is this top here is your quotient, which is what? X raised to power 3 plus what? 2x squared minus 7x minus 1. Okay? And then you tell them your remainder. Your remainder is equal to what? The last thing here, which is 0. You can tell them, it will fetch you a mark. Tell them, since the remainder R is equal to 0, therefore, this person dividing x minus 5 is a factor of that f of x. Is a factor of, sorry, the p of x, sorry, is a factor of this p of x. And what is p of x? P of x is equal to what? X raised to power 4 minus 3 x raised to power 3 minus 17x squared plus 34x plus 5. Okay? So whenever you get that the remainder is 0, it means that the person dividing is a factor of the person who he is dividing. So since we got that remainder is 0, we concluded that what? This person is a factor of this person. Okay? That will fetch you an extra mark. All right? Though we are not asked that, Sha. So, but writing it shows that you know what you are doing. Yes, and it will fetch you a mark. But if it is not 0, you can still conclude. Maybe we got maybe 5 or anything. We'll tell them, since the remainder is 5, which is not equal to 0. For example, maybe we got 5, maybe. So we say that since the remainder is equal to 5, which is not equal to 0, we will now conclude that this is not a factor of this because we did not get 0. So that is how to do it. So if you did not get 0, you tell them that it is not a factor. But if you get 0, you tell them that what? It is a factor. So the next thing they say we should what? We should prove that the sum of the n term of a geometric progression is given as prove that the nth term of a GP is Sn is equal to a in bracket of 1 minus r raised to power n all over 1 minus r. Okay, there, that is if r is less than 1. All right. So now this thing is very simple to prove. I'll just show you just 3 lines and then you are done. I'll just show you what to do. Solution. The first thing you need to know is what? The nth term of a geometric sequence is given by the Tn of a geometric sequence is given by ar raised to power n minus 1. What does it mean? And don't forget that the first term don't forget that the first term is A. So if the first term is A, comma, the second term is gotten by the previous person times R. So the next term is AR. Okay. Then the next term again is what? Multiply this one by R again. You have AR2. Once you get here, just do dot dot dot. Then comma. The next person is what? AR raised power n minus 2. Please. And then the last person is now AR raised power n minus 1, which is this formula. Okay. Now the next thing to write is what? Just say Sn is equal to, anywhere you put comma, change it to plus. That's all. So anywhere I see A here, plus AR plus AR squared plus AR raised power n minus 2 plus AR raised power n minus 1. Okay. Then the next thing you need to do is just to use R to multiply these people, and then I'm done. So multiply by R. Tell them multiply by R. So I have what? R times this will give you RSN is equal to what? Please let me call this equation 1. Okay. Multiply by R. R times this is this. R times this will give you AR plus R times this one will give you AR squared plus R times this one will give you AR cubed plus R times this one will give you AR raised power, to remove 1 to be raised power n minus 1. Okay. Plus R times this one to remove this 1, so it will remain AR raised power n. Now once you get to this place, you will now consider what they gave you. In the formula they gave me, don't forget that the formula of a geometric sequence is 2. The first one is what? Sum of a geometric sequence is what? The first one is what? A in bracket of 1 minus R raised power n all over 1 minus R. And then the second one is Sn is equal to A in bracket of, in this one, 1 came first, but in the other one, R comes first. You see? So it depends on the one they ask you to prove. All right. So since I am asked to prove the one that 1 started first, so I will tell them equation 1, sorry, call this one equation 2. So I will tell them equation 1 that does not have R minus equation 2 that has R. That is if I'm proving this one. But if I'm proving the one that has R first, I will say equation 2 is the one minusing equation 1. Please, you have to be very careful. Biko, please. So I'm having, so since I am proving this particular one, so this one that does not have R, I will tell them what? Equation 1 minus equation 2. So what does it mean? Now, don't look at this. Just come and write for me. This one, watch me. Sn minus this one, Rsn is equal to. Now, when this subtract, look at what you do. Just copy the top right hand top. Just write the top here. This top here, that's the only thing I want you to write for me. The subtraction of all these things will just give you this top. Don't know how to do it. Just know that it will give you this top. It's giving me A in bracket of 1 minus R raised power n. Okay? Then you are done. The last thing you need to do for me is what? Factorize. What is common between these two places is what? Sn in bracket of this divided by this will give you 1 minus this divided by this will give you R, because this will cancel this. R is remaining. Okay? Is equal to what? A in bracket of what? 1 minus R raised power n. You see that? So the last thing now is now to make Sn to stay alone. If Sn stays alone, Sn will now be divide everybody by 1 minus R. This one will come down to have the what? A in bracket of R raised, 1 minus R raised power n all over what? 1 minus R. That's all. Proved. You are done. Okay? This is very simple. So try the other one. Try doing this one minus this. Tell me what you get. Okay? You upload it in the comment section. It's very simple to prove. The first thing you do is what? You don't even need this one, sir. The first thing you do is what? List the terms of a geometric sequence. Then the second thing, anywhere you see plus, comma, change it to plus after writing Sn. The next thing is to multiply by R. Then you subtract according to the formula. Know if you are using equation 1 to subtract equation 2 or equation 2 to subtract equation 1. Then you factorize and then you have gotten your answer. That's all. It's not difficult to prove. So please try it. Like prove it like 3-4 places until you master it. Okay? Just try proving it in 3-4 places. Then it will become part of you. Then you are good to go. Right? So the next question Question number 5A. We're almost done. We just have one more question. So 5A. Question number 5A said, they said if alpha and beta are the roots of x squared minus 12x plus 7 equal to 0, then they say find I alpha squared plus beta squared. I alpha over beta plus beta over alpha. I 1 over beta plus 1 over alpha. Right? Okay. So now this is very simple solution. Now anytime you are solving anything that has alpha and beta, the first two things you must get is alpha plus beta and alpha beta. Please watch my video on roots of quadratic equation. You understand this very well. So the first thing I'll tell them that what? That you know that the general equation is ax squared plus bx plus c is equal to 0. So if you compare this, you see that a is anything that is standing with x squared and nothing is standing with him. So there is an invisible 1 here. So a is equal to 1. B is the one standing with x, which is minus 12. B is equal to minus 12. C is the one standing alone. So C is what? 7. So the first thing you need to get is alpha plus beta. And what's the formula? It has a formula minus b over a is the formula, which is what? Minus into that minus 12, then over 1, which is minus times minus plus. So I'm having 12. Then the last one is alpha beta. Alpha beta is what? C over a, which is what? 7 over 1, which is what? 7. Okay? So before you start answering any question, so let's answer the first one. The first one said alpha squared plus beta squared. It has a formula. The formula said alpha plus beta all squared minus 2 alpha beta. Okay, please try and watch my video on roots of quadratic equation. You will see how we got this formula and you can memorize it. Okay, so now substitute. You see why we need to get these two things I say you must get, because it's always in the formula. So if you now put it, you have 12 squared minus 2 into 7. So what do you have? 144 minus 14, which is what? I think 140, 130, 130. Right? So the next one, anyone in fraction is just to find LCM. Like this one is in fraction. So let's find LCM. So alpha over beta plus beta over alpha. So the LCM of this and this is simply alpha beta. When these two divide, this is meaning alpha. Alpha times this will give you alpha squared, plus when this divide this is beta. Beta times this will give you what? Beta squared. So what do you have? Don't forget the value of the one at the top. We have gotten it as what? 130. So 130 all over alpha beta. Alpha beta is 7. 130 over 7 is your answer. So I said 1 over alpha. Sorry, 1 over beta plus 1 over alpha. So what do you have? The LCM again of this and this is alpha beta. So this divide this is alpha. Alpha times 1 is alpha. Plus this divide this is beta. Beta times 1 is what? Is beta. So what do you have? I've gotten alpha plus beta as 12 divided by alpha beta as 7. So 12 over 7 is my answer. So I am done with this particular question. So alpha and beta question is the cheapest question and number one question you are supposed to solve. Rush it and smash it immediately because it is not difficult to solve. So the next one, 5B, question number 5B said, insert 5B said, insert 3 arithmetic means between 11 and 31. Okay, this is a very simple question. Solution. So now let us insert it. Let's say that let the three of them be x, y, z. Let the three arithmetic means be x, y, and z. So if you insert it, you have 11, x, y comma z comma 31. All right. So now what does it mean? You know that in an arithmetic progression, the first term is this. The first term is a. A is the first term, which is 11. So count the last one you are seeing. 1, 2, 3, 4, 5. So it means that the fifth term, and the formula for the fifth term is a plus 4d. Formula for 10th term is a plus 9d, because formula for nth term is what? A plus n minus 1 bracket d. You understand? So, and they say that this fifth term is equal to what? 31. So if I can put my a is 11. So 11 plus 4d is equal to 31. So 4d will now be what? 31 minus 11. So 4d is equal to 20, right? 20. So my d will now be what? 20 divided by 4, which is 5. Once you have gotten your d, you are done. So don't you now tell them that this is first term, second term, third term, and fourth term. And to get each term, so the second term simply means a plus d, the first term plus d. So which is what? 11 plus 5, which is what? 16. This third term simply means the second term plus d again. So which is what? That's 16 plus 5, which is what? 21. The fourth term, which is z, don't forget that this thing is z, and this is x, equal to this one is y, equal to then z, equal to the z is the fourth term, which is what? That third term plus d again, which is what? 21 plus 5, which is 26. So the arithmetic mean are 16, 21, and 26. Write it. The arithmetic means are 16, 21, and 26. Very, very simple. Okay? So let's move to the last question, which is question number 6. The last question, which is question number 6. Okay, so 6a, question number 6a said, if tan alpha is 1 over 2 and tan beta is equal to 1 over 3, then I say find tan alpha plus beta. All right, so this is very simple. Solution. Now it has a formula, that is tangent formula, tan formula. It said that tan alpha plus beta simply mean tan alpha plus tan beta, then all over 1 minus tan alpha, then tan beta. You need to cram this formula. You need to memorize it. So this one gave me 1 over 2. So 1 over 2 plus 1 over 3 all over 1 minus 1 over 2 times 1 over 3. So if I solve the numerator, I'm going to have that the LCM of the numerator is 6. 6 divided by this is 3. 3 times 1 is 3. Plus 6 divided by this is 2. 2 times 1 is 2. Then divided by 1 minus 1 times this is 1 all over. This time this is 6. Okay. So the numerator is giving me 5 over 6 over the LCM there is what? 6. 6 into this is 6. 6 times 1 is 6 minus 6 into this is 1. 1 times this is 1. So I'm having 5 over 6 over 5 over 6. So which is what? 5 over 6 divided by 5 over 6. So the answer is 1. Or you change it. You change it 5 over 6 times now 6 over 5. So this cancel this cancel this. So I'm having 1 as my answer. So the answer there is simply 1. Right? Very simple. Very, very simple. So all you need to know is just to know the tan formula. All right? So the B part of it, the B, 6b. 6b said express in x plus yi form of the following complex number, of the following complex number. All right, the first question there, I said 7 plus 2i plus 3 minus 2i. Okay, I question there said 4 minus 3i minus 3 minus 7i. All right. I said express 4 plus I over 3 minus I in the form of a plus bi, where a comma b are elements of a real number. Okay, these are very, very simple questions, and then we are good to go. We are done for this particular year. So the next video, we move to the next year. Solution. They just want us to add up this complex number. So we have, first of all, 7 plus 2i. Okay, plus times this is plus 3i plus 3. 4 plus times minus is minus, so minus 2i. So in this case, real we add the real, and the imaginary we add the imaginary. So this plus this will give you 10. This minus this will give you 0i, so 10 plus 0i. Okay, leave it like this because they say in terms of x plus yi. Okay, so you must leave that 0i there. This is for my I. So my I said 4 minus 3i. The minus is the one multiplying the left hand side. So minus times this will give you minus 3. Minus times minus will give you plus 7i. So the real go to the real. 4 minus 3 will give you 1. Right? Minus 3 plus this will give you plus 4i. So I've left it in x and yi. So the last one, I, is just to rationalize. We don't leave a we don't leave a complex number at the denominator. We have to rationalize. And we are rationalizing with the conjugate. So I have 4 plus I all over 3 minus I. You will tell them times. The conjugate is simply to change the sign. So times 3 plus I over 3 plus I again. All right. So what do we have now? Well, let's just multiply. 4 times 3 is 12. 4 times I is 4i. I times 3 is 3i. I times I is minus 1. Please, I times I is I squared, and I squared is minus 1 over 3 times 3, 9. 3 times this, 3i, minus I times this, minus 3i, minus times plus is minus. I times I is minus 1. See the way I'm doing it? So you now have the real to the real, the imaginary to the imaginary. So real, 12 plus minus is minus. So 12 minus this will give you 11. 4 plus this will give you 7i all over. This and this is gone. So I'm left with 9. Minus minus is plus. So 9 plus 1 is 10. I'm left with this. So now share it for them so that the real will go separate and the imaginary will go separate. So I have 11 over 10 plus what? 7 over 10i. We have left it in the form of a plus bi. So thank you very much for watching. Please like, share, and subscribe. God bless you.